Assalamu alaikum. Myself Anika, registration number 21TE54. This is our DSP lab number 5, and in this lab we will discuss about the discrete Fourier transform and its inverse. So we have taken our first function, that is about the discrete Fourier transform, where we have taken the n, that is equals to the input signal, and then we have taken our value of x. This is our input signal, and down here we have taken some value for x. Then we have used our for loop, that is basically used to give the range for any function, and here its range is from 0 to n minus 1. And down here we have used a formula for discrete Fourier transform. This is the formula for discrete Fourier transform, and then we have used the n function. In the next lab, we have done the same thing, but this function is for the inverse Fourier transform. Everything is same, but down here the formula will be different. So this is the formula for the inverse Fourier transform. This is the next task, and in this one, these are our four signals x1, x2, x3, and x4. Here the capital X is used for the discrete Fourier transform, and the small x is used for the inverse discrete Fourier transform. Now we have to display our results. So for that we will do for the discrete Fourier transform, and then we will take inverse of that. So it will be inverse discrete Fourier transform. Now if we run our function, this is our output of all this, and that's it. So this is our next lab task, and in this one what we have to do, we have to find out the discrete Fourier transform of the signals that are already given in the question. Total we have 11 signals. So first of all, these are the 11 signals that were given in our lab report. Now we have to find out the Fourier transform of all of these signals. So these are the commands for the signal that we have used. FFT. Here we have used the command FFT in the MATLAB. Whenever we have to find out the Fourier transform, we will use this command. After that, what we have done, we have to we will have the Fourier transform of our original signal. Uh, After finding the Fourier transform of our signal, we have to find out the magnitude spectrum. So in the MATLAB, we have used the command of absolute and stem for that, for finding out the magnitude. So as there were 11 signals, so 11 subcommands were used, and this is the output of our signal. And as there were 11 signals, so there is 11 outputs. This is the first signal, and how the magnitude is coming. First of all, we are finding our Fourier transform, and after that, when we have used the command of stem and absolute, and we have used the subcommands, then we will have our magnitude spectrum of all the signals. These are our 11 signals. This is our lab task number 3, and in this one we have a signal that is given, which is x is equals to 1 2 3 4. This is our given signal. We don't know the real and imaginary part of this signal. First of all, we have to find out the discrete Fourier transform, and after that we have to find the magnitude spectrum and the phase spectrum in the real and imaginary parts. The real parts are again here, as we have to find the magnitude. So as already told, we have used the FFT command that is used for the Fourier transform, and after that down here we have used the function of display, and we have used the real and imaginary for finding out the real and imaginary parts, and we have to display the spectrum, magnitude spectrum and the phase spectrum. So for the phase spectrum, we have used the angle command. So we have our inverse Fourier transform at the end. Now what we have to do, we have to run this function, and when we run it, we will find out the output. And let me show you the output of our function. That is this one is our output. Yes, in our output, the first one we have this frequency domain. This is the frequency domain. Down here we have the real part, then imaginary part, then magnitude spectrum and the phase spectrum, and at the end we have the time domain of our function. In the last lab task, we have to take a signal from our task number 2, and we have to perform the discrete Fourier transform, the magnitude. We have to find out the magnitude spectrum, phase spectrum, and the power spectrum of that signal. So here I have just taken a simple signal from my task number 2. This is the signal that I have taken, and after that I have done the Fourier transform. I have to do the Fourier transform. So for that I have used the command of FFT, that is the basic command which is used to do the Fourier transform. And then I have to hold the length of the signal and the range of the signal, and then we have to plot the magnitude spectrum, phase spectrum, and power spectrum. So as I have already told that for the magnitude spectrum always we have to use the command of absolute command. Then we have to give the title for that, that what we have to show on the x-axis and what we have to show on the y-axis. On x-axis we have frequency, on y-axis we have magnitude, like that. We have then again we have to use the phase spectrum, and for that we have I have used the angle command, and again I have given the title. And for the power spectrum I have used the formula, and in that formula we have to multiply for the power spectrum. Now we have at this side, this is our output signal. First one is for magnitude spectrum, second is for the phase, and third is for power. And you can see all of these are very different from each other. It's not same. So that's it. We have done our all the lab task.